Hi, good afternoon. My name is Erwin Williams again, and welcome to another edition of Teleios Power Hour Live. For those of you who are now joining us or joining us for the first time, this is episode 9, and at this episode we have a special guest. We're going to be talking with Sinath Gooding. Teleios, he has a different name. We'll get into that a little later on, but Sinath will be sharing with us interesting innovations on the Raspberry Pi. Not super interesting, but fun all the same. We are at Teleios. We have Power Hour every week, and generally the episodes are internal. So we look at technologies that the developers care about, or we're learning, or we found interesting to help us with our work, or help us just understand technology some more. So as we've been doing for a little while, Power Hour Live allows us to share one or two of the insights we've learned. Over time, we've found a wide set of interests at Teleios Power Hour Internal, and we decided, let's make sure and try and share some of that stuff with everyone else who takes a view of our show online. Today, we're looking at the Raspberry Pi. As we mentioned in our shorter blurb yesterday, we want to look at getting an LED lit on the Pi, but to make it interesting, we want to use 4 or 5 different ways to do that. This session really is driven by Sinath. He did the research, he made sure the languages worked, went through all the troubles to make sure things made sense, and he's sharing that stuff with us today. As I'm doing this, so Teleios Power Hour really is filled with a bunch of engineers from Teleios. One of our engineers, Ryan Sripat, he will share with us a bit of news a bit later on. I realized Ryan was asking me for the link for the episode, and I didn't share it with him. So yeah, he can't actually share his news just yet, but that's all right. We're working this thing out. In the meantime, let's have Sinath come on and share with us what he's learned so far in getting the Raspberry Pi to light an LED using 4 or 5 different languages / approaches. Sinath, you ready?
Hello, test. And I hear no.
Yes, Sinath, you're on. You're fine.
Yeah. So for this Power Live, I have been in preparation. I've been attempting to run some basic code to blink an LED, but not just in like one language or one way. I was exploring different ways in which you could do things, and blinking an LED being the first step in exploring any sort of different way. So before I explored 4 other languages besides Python, and turns out life with Python Python on the Pi is nice. And life without Python on the Pi, well, that's a bit more involved, especially if you have a potentially bootleg Pi. Right? So a quick rundown first. We'll look at communicating with the GPIOs directly in terminal, and writing a small loop there. Then we can move to a bit simpler with, well, a bit more complicated but still simple with Python. Then Java, JavaScript, C and C#.
Right.
The circuit. Sorry. Yeah, one more thing. Yeah, so the circuit. I don't know if you all seen the camera, the stream for that. So the circuit is we chose to keep it simple. So nothing else besides basic Pi, and I'll explain the circuit connections soon. But it's just a basic LED to the GPIO to register to ground.
So, Sinath, just before we go on, for the sake of our audience, Sinath is one of 2 interns we have this year, Sinath and Joshua. Sinath is an electrical engineering student, and myself, I did computer science. So we were telling Sinat a while earlier. When we did computer science back in undergrad, which for me was a few years ago, it's we didn't really do stuff with LEDs and circuits and that kind of stuff. So the most basic breadboard setup to me is fascinating and wonderful fun. I've since figured out some more about it, but see that I see to the but I can see the breadboard and I can see the LED and I feel the connections from the board to the Pi. What are these stuff? What are those white cool things down low on the board?
I hear you. So sorry, those are actually not inconsequential to what we're gonna build, but
Right.
those are just ICs. You could probably different things look similarly in terms of uh bits like this, but you would
Yes.
normally just check the the serial number to get the spec sheet now. So
Right.
these are, from what I'm seeing, one is a resistor pack. So like it's just like you connect you connect yeah, they just connect whatever peripheral. So it's neater than having a resistor like this.
Yes.
The other two I think are just um some sort of, I see. I can't say for sure because I can't, because the things are upside down. But yeah,
All right. Cool.
inconsequential to what we're gonna do.
Fair
But
enough.
lots of cool stuff though. Very
Yeah.
cool stuff.
Great.
And
So you're going to show us the terminal first, I think.
anyway, well, I'll show you. I'll show,
Keep over here destroying all pies apparently.
I'll show like a circuit diagram so you get a little understanding of how the thing was set up.
All right.
So just everything there. So real basic circuit. Oops. Right. You seen it?
Yeah, definitely.
Right. So generally, like a simple explanation is, so the Pi has these pins here. Some of them are just constant highs, so like constant so it's like a voltage basically, always being there. Some of them are for UART and serial. Some are for GPIOs. So GPIOs stands for general purpose input output, and that's what we'll be looking at today. So we'll be changing pins depending on whatever pin we choose to activate with the code. So this is just more like a general circuit. So one goes to the LED, which will be either output in the high or the low, and then the resistor, and then back to ground. And well, I won't get into the specifics too much, but calculating and ensuring that you have the right values for the resistor depending on the item that you have in the circuit is extremely important in terms of the breakdown values for the item in question. So like in this case, you would calculate the voltage drop across each of the things to make sure that too much voltage not dropping over anything, and you would have the you would have enough, well, not too much and not enough, because if the resistor is too large, then it'll have a larger voltage drop across it, and then the LED wouldn't light as bright. But too small and too much current could go through the LED, or if you have a more sensitive device. So in terms of that, the calculation of the circuit is extremely important. So that's it for the circuit. We start with terminal. So with wire and Pi is like a library. So it's like a way to give you GPIO access, right?
At the terminal, right?
Yeah, at its own. Well, it's also a library that you could use to different code, as you'll see when we go.
Okay, cool.
So so first we'll just look at all the GPIO pins. So GPIO read all. Is that displaying properly? Yeah.
Right, so I'm seeing it showing me all the pins are available on the Pi at the moment, right?
Yeah. So and it shows. So this is what Warren Pi could allow you to refer to the pin to, and like if you're calling the pin in code or anything, this is the name, like the label of the thing, and BCM stands for Broadcom chip, system chip. So basically, is the hardware names on the of the pins themselves. So you can refer to the pins as that too. These show, so you could set the pins to be input or output. That's pretty important because you can't output from an in, and you can't take input from a sensor or anything from a out. So seeing as we want to output to the GPIO, we will want to set it to out. So right, so we do that GPIO mode. We deal with pin 7. And you can see it sets it to out. So pin 7 on wire and pi, GPIO 7 out. Just to show you that we can, again, I'll set it to in. And sets to in. And you can see that it's outputting a logic 0. So the pi is, so another important point. There are breakout boards to be used for the pi so that you know what pin is what. But if you don't have a breakout board, then you gotta be able to know what pin is what. And how you do that is you look for the pin mapping. You know, Google is your best friend. So these are the pin mappings, and you gotta make sure and orient it with your spatial reasoning, however, and make sure the pins match whichever pin you want to call. So any circuit, you can see I don't know how clear you can see it. You can see which 2 pins that it connected to really. And if it's pin 7, GPIO 4, and ground, right? So remember we need a high, and the circuit has to be connected back to the ground. So we want to output a 1 on GPIO 7 wire and pi pin 4. Sorry, pin 7. So to do that, I'll do that. Oh, oops. Oh. Yeah, it is supposed to change to 1 though. Yeah. I may have to reboot the pi.
Oh, really? How come?
Anyway, this kind of thing always happens.
Nice.
Things could be working, and then pressure.
That's nice. I see Ryan is saying adversity breeds ingenuity. That's
Wait,
okay.
boy, that's that's real unfortunate though. What are you
Nah,
gonna do?
man. Just reboot will go again. Have you started reboot already?
I'm not gonna start it. So
What do you think could cause that to not work? Because of course this is a big part of our life, right? You know the thing's supposed to work, and it just doesn't. What could cause
yeah,
this
boy.
scenario sometimes?
Um, well, after you do plenty stuff on your Pi for a while, sometimes just resetting everything, just put things back to how it should be. It's like when you reboot a router or something, you know.
Got it.
Sometimes it just take a restart. Like even your Windows computer.
Yeah, that makes sense. So you're remoting back into it.
Yeah. So using the Windows remote, the desktop client.
Right. I was Ryan's on the call, Ryan. I don't know if you saw a recent post by Scott Hanselman about spending several hours trying to debug an issue with .NET Core on the Pi. This reminds me a bit about that.
.NET Core on your Pi, right?
Doesn't he have children?
He does.
Where he getting time to do this?
I don't know. So you're gonna try again, Sina?
Yeah. So I check any pins again. So I set back to in. So I'll set it back to out. Set to out. Right. So you can see that on the circuit, when I write wanted, it's in on the LED, which means it output a high on pin 7. So a high or logic 1, and the LED turns on. So the voltage is now 1. It was 0 before, so the logic level is high, and then you can turn it off. Right in 0 to it. Oops, I didn't put the pin value. Sorry, 7 0. Right, and the LED turns off. Yeah.
Nice. What I like from this, CNAF, is you may actually want to test a set of interactions with a sensor, or not just an LED, something else on the board. You want to make sure it's getting the right. You are talking to the right pins. I love that you can just come to the command line and run some quick tests rather than writing a bunch of code to compile and make sure the thing actually works.
Yeah, definitely. Like without this, you would have to dig up on a lot more stuff. Plus, you see that even the most basic, simplest things could just not work when you need it to the most. And something as simple as a reboot could just help your life.
Right. Have you had to do a lot of reboots?
Yeah, boy.
Over the course of this week?
Too many to count, boy.
Too many.
Real stress.
Very cool.
Especially
next.
Right. So we turn it on and off manually, but we want to turn it like when I write a loop in Bashna, so in terminal, fit a loop and blink the LED.
Okay.
So as you would, I mean, it's not too complicated. It's a little for loop. We'll loop it about, I don't know, 4 to 5 times.
You have 2 ins.
Oh, thanks, Ray. You saved my life. So we look 4 times, and just as before, how we turn the pin on and turn the pin off, same kind of logic. So GPIO write 7-1, and if like if you think about it, the steps, like when you're now into program and everything, you think about the steps, right? And to blink something, you'll turn it on and turn it off, but you have to make sure and wait in between, or else you won't see it change now. So
Right.
you have a delay. We just did it for 1 second.
You can make it on if X even and off if X odd.
Sorry, I didn't hear what you say.
I was saying you could make it on if X were even and off if X is off. It is odd.
Yeah, you could. You could.
What unit says sleeping?
So conveniently, it's just one. It's just seconds. So I'm sure how you get less than 1 second, but I'm sure it's not too complicated. And if you look at the circuit, it blinked 4 times. I don't know if you saw that.
We didn't run it again.
Alright, cool. I actually really like how that I could go back to commands even when I reboot. Real vibes.
Nice.
Alright, cool. So you see, when it finishes the loop, it ends. So right, so that's terminal. Next, we should do some Java, I guess. Sure. And Java. I mean, Java wasn't too complicated either. Like there's a certain set of languages that are pretty easily used with the Pi, Java being one of them. So, in the interest of time, I will just show you the code. I'm just gonna pull it up and bring it onto the screen. Hold on. I had everything pulled up, but since I had to reboot, it all went away. Live by. All right, so I should do this. I don't know how again. Right?
Sorry, I was muted. You're just going to show us the Java implementation.
Yeah, but well, I don't know. Should I go through the code itself, or should I just show you how to run the Java?
I want to see the code.
All right, cool. So, real simple code. Same kind of logic all around, except the only differences are that you'll see are the syntaxes. So, it's actually pretty easy to write and to interpret. So, in terminal. So the first thing you'll do is you look for the directory. If you want to call it in terminal, go to that directory, and then you need to compile it. So the name of the file is blink.java. You do Java. So this would be the command to compile, and so it compiled, and then you'll see anything that so this wasn't here before. In compiling,
Right.
it's generated that file, and then you run that file.
So your Java file just essentially wrapped the GPIO command.
Pretty much. So just make sure you see it blinking.
Yeah, it's not.
Right.
It's loading. It's blinking, but it's still loading. It's not very sharp
Like,
just yet.
I mean, it's just looking like a blinking LED at all, yeah. But after all the stress that I went through so many times to get things to work, it just looked like the best thing in the world. Right? So that's what to do with Java.
Right.
And so next, I guess we'll do JavaScript. So we'll use Node. So I'll get the JavaScript. Hold on. So again, the same kind of logic, except the syntax changed. You always look to set the direction of the pin, and then set or output either logic high or a logic low. I will not hear you again, but
Apologies.
yeah.
See that? This is a node, and they're using a package called GPIO. So this
Yeah.
different from the. If can you go back to the Java file that you showed us a little bit before? So you can see here in your Java, your class is dependent on essentially giving a, when it says runtime runtime.get runtime, it looks like it's literally going to execute a command on what we could consider to be the command prompt.
Mm-hmm.
So it's the same command you had issued a while back, runtime exec, and the same line, right? Can you switch back to Node?
This thing in a way,
Probably could minimize Java.
oh, not that.
I mean, you can minimize everything too if you like. It's all right. Yeah. So and in Node, instead, of course, you're using a package from Node to more programmatically issue the, well, more in a more object-oriented way issue the commands, right?
Yeah.
Nice.
So for Node. Sorry, I can switch in between the Pi and my laptop. That's why you'll see a bit of dead movement for a while.
Yeah.
So 1 second.
So you're working from your laptop and you're also remoting into the Pi to get this done.
Yeah, so there's real screens here.
Nice.
Real vibes too, but it's just a little bit clunky if I had to move between both of them for the streaming. Very good.
Mm-hmm.
So run Node. Well, I mean, the stuff already written and compiled, so we could just so we'll move to the directory that it's in. It's stored in, which is this one. So there's the JavaScript file that we want to run.
Mm-hmm.
So we'll go to there, and then we want to run the file. Oh, so just one thing before I run it, just want to check which pin I used. So GPIO 17, and I'll find which pin that was.
7.
using my handy dandy pin mapping. Lusco's reference. And
Only you got that scene at. Unfortunately, the rest of us don't know who Blues Clues is.
how was that possible? Hey, so GPI 17 is this one, right?
Yes.
So if you want to go to this one, I don't know if I could illustrate it too much, but
I'm seeing it highlighted right now.
no, I mean like me changing the pins now.
Right.
So okay, so like as a point of reference, ground here is my brown wire here, right?
Hold on. The pie isn't up. It's up now.
Right.
Great. Go ahead.
So and and we were at pin 7 GPIO 4, which is where the red one is right now. So if you want to go to pin 11, which is on the other side of the ground, that's essentially what I'm just doing. I'm just going to switch pin. This is where you have brickboard boards for, so that you have to go through all this.
Right.
But adversity breeds ingenuity. And way around, way. So now to see like the pin could execute this. Did it? And you seen it blinking? Or did I move the camera? Yeah. Yeah.
It gave me one blink. I'm not satisfied. There you
Now
go.
it's
There you
five
go.
blinks.
Nice.
All right, cool.
Great. So far we've seen terminal, Java,
JavaScript.
and JavaScript. What more do you have for us?
So all right. So next we'll do some C. And again, excuse the. I mean, I'll be on the Pi right now. So for C and C Sharp, I used this thing called MonoDevelop. So it's like this open source tool that some devs made so that you could write and compile C and C Sharp. It was cool, but it was also real stress because some errors just didn't make sense, especially if you try and do things in like if you just try and make it fancy with some object oriented stuff, it would just not work, right? So instead, I will run. I'll show you how to compile it in terminal. Right. So
You have to change directories, right?
yeah, I'm gonna do that now. Sorry. So it's kind of a rush, but you cannot think of it as a rush too, because.
What, compiling from the command line? No, that's not right. That's all right.
But I mean, if you want to do development and something, you'd use Mono. But if you want to get a job done, no.
No, you could do both. We use both all the time. Whichever one you're more comfortable with is okay.
Right. Right. So you would, because I compiled it already. Hold on, I just want to clean up the folder, because you would compile it to a new folder for a new solution.
Right.
Oh no,
Oh no, what? What's up?
the camera that's streaming the circuit powering off for some reason.
Oh,
Even though it plugged on though.
oh, let me come out.
I guess it was discharging faster than it was charging.
So, Sinat, you can show the code for the last two while we set up a replacement camera.
What was that, sorry? My headset
You
was off.
That's all right. You can show the code for the last two while we set up this new camera.
All right, cool. So again, real basic. Using the wire and pi to refer to the GPIO pins. And I could actually talk about this the C sharp by the time. So the C sharp was the most pressure.
Mm-hmm.
Not if I upload it now. And things like, hold on, like so this was the way that worked essentially. And in this way it actually reveals some pretty cool stuff, so that like the file that is sort of being read by the hardware to do GPIO control. That's what you're gonna write to with like that file. You're gonna write to that with C sharp commands. And I thought that was real cool because I didn't know I could control GPIO like that. So essentially, what happens is you'll write to this export file here. So that's what's supposed to happen with the code, right? So as you can see, it commented out now, but the plan was to write it here. But what ended up happening is, I don't know if it's because everything was happening so quickly or what, but when you write it with the C sharp code, it would not give itself permission to write to the file now. it was a Linux thing or what, but that was some stress. So
So Ryan's making an interesting point here. If you see his question, isn't a file just another output? So
well,
it's using
sorry.
file behavior, but
Yeah.
file behavior just ends up writing bytes somewhere. So by indicating write the bytes to the folder, you're actually issuing commands. And he's saying here, if you see his comments, Linux treats them all the same. So we just could probably stumble on more deeper understanding of Linux. Do you think so?
Yeah. Yep. Exactly. So, right. So the workaround for this now is that I'll write to the file using terminal directly, using some sudo command. So I have admin privileges, and that will essentially do what this line and some other lines that I had here would have done. And then we can execute the code. So
Right.
I guess I'll wait on the camera.
Now, you know what we could do? So we've seen this code. We've seen your C. How many languages is that? That's all 5. So C now.
Python, yeah, 6 including terminal, but I don't know. It's not a language, but
We'll take that. I
Bash.
think we could wrap up there.
Bash is a language, right?
Bash is a language according to some people.
Yeah, Bash.
We could wrap up with that while we actually almost finished with this, getting this camera set up. But the fact is, what we're going to see is just the light blink again. And I think hearing from you, particularly this last bit about understanding Linux, was a big deal. I'm really glad we did that.
Well,
go ahead.
I'll at least just share the editing of the file. So
right,
you go to this directory, and then you wanna open. So you wanna open this. So like, okay, for instance, if I was to try and edit it here, most likely it would have not given me access, and I want to be able to save any changes to it.
Right.
So we could do nano is like a so you get edit text in the command prompt in the terminal. So nano export. All right, 26 it. So we could use pin 26. Oh well, you can't see much change the thing anyways. But whatever.
Oh, we can.
I will. Oops. Whoa. I'll open it using leaf pad.
Is this muted?
So you see, right into the export made this folder, and what we want to do is write to essentially what this code is going to do is write the file that would indicate the direction, and then write the file that would indicate the value, and then you would do the normal delay, and then write again to the value, delay, and then loop, and then that would essentially make it blink. So that's about it, Owen. To get me to the again, right?
Yeah, Sina, really good. I was glad to hear your learnings and your understandings around not just the languages, but the environment or the context of developing for the Pi. I'm sorry for the echo if you're hearing it on the recording as well. There's one question from Anthony Victor. He said, could you not also request the permission using a sudo root request? And yes, you could have, Anthony. But I guess in the interest of time, just to wrap things up, we'll leave it there for the moment. To wrap us up completely today, we'd have Ryan share with us that news segment that was supposed to start at the beginning of today's Power Hour Live. So, Ryan, are you ready?
I sure am.
Great.
So here we have another episode of Cloudy with a chance of news. And today we take a look at I Can Has Cheeseburger, or not really I Can Has Cheeseburger, but more this site that I found on a podcast called iCanHas.net Core. What is used for? The site is used, what you do here is that you upload your packages config from your .NET project, and it will determine whether or not you're able to use .NET Core, or how easy it is for you to port your application to .NET Core, also called .NET Standard, right? So as you know, most of the applications we usually make inside of Visual Studio, unless you say otherwise, you're going to make it using the full .NET Framework 4.6 or whatever is the most recent one. And if you want a certain level of interoperability, I don't really want to call it interoperability, you try to write your application using the subset of the .NET Framework called .NET Standard. And this website would examine your packages config and let you know how close you are to move into .NET Standard. So here we have we have a little project here, and I've uploaded the packages config from the build folder, and you can visualize the dependencies here. And let's expand that a little bit here. So we can see the project here. The green items are supported in .NET Standard. So these are the packages that my project is using that use that are portable to .NET Standard. And here is one package that is unsupported in .NET Standard. Pretty surprisingly, the configuration manager. I'm sure that there's another one we can use. There's another package we can use like that. In addition to doing it in that way, to uploading your packages config, you can scan a GitHub repository. So here we have one of the Teleios GitHub repositories, and it will do the scanning for us and let us know how close we are to porting this particular application to .NET Core. As you can see, it's using Unity and the CSL, and neither of those are supported in .NET Standard. This has been another episode of Cloudy with a chance of news.
Thank you very much, Ryan. I think we could have an entire session on that graph viz and how it does this cool visualization as well as a slight side mention. Anyway, thanks for that tip. We will definitely put it to use because we've been doing .NET for so long. We have quite a few projects we'd like to figure out how to get into .NET Core. We've had a presentation today by Sinath Gooding. He's one of our 2 interns this year. Sinath is an electrical engineering student. We at Teleios, we have special names for our interns. They're all postfix with DANs. So Sinath is also known as Hydro Dan. If you see him in the road and you say, Hydro Dan, because he's really into that kind of technology, he'll answer to the call immediately. So do try it. Do try it. Anyway, thank you, Sinath. We saw 5-6 ways of interacting with the Raspberry Pi, and we learned more than just about lighting and LED. But we understood a bit more about how GPIO works, the packages you need, and of course, sometimes when you need to do a quick restart once or twice to get things going. Really well done, Sinath. We have you here for 6 more weeks or so, so we're looking forward to even more cool stuff with you as we go along. So cheers. Thank you, audience, for joining us. I know we had a pretty good community of other Teleios engineers watching us, and well as asking and answering questions. So thanks, guys. Thank you to our producer, Keisha Griffith. Thank you to our set coordinators all around downstairs the office. Thank you to Ryan for Cloudy the Chance of News. Thank you, of course, to this show's sponsor, Kevin Kellowan, our Chief Operating Officer at Teleios Systems. This has been Teleios Power Hour Live. Cheers.